Have you ever stopped to think about the fact that our entire universe runs on a kind of source code? I'm talking about a set of invisible rules that govern absolutely everything that moves, from a planet orbiting the sun to you just walking down the street. Well, over 300 years ago, one person, Sir Isaac Newton, figured them out. And today, we're going to break them down. But let's not get ahead of ourselves. Let's start with something we've all felt. You're on a city bus, it's moving along, and then bam, the driver hits the brakes. The bus stops, but your body lurches forward. What's going on there? What is that invisible push?
Well, it turns out you're not being pushed at all. You're actually just following the rules. And these aren't just any rules. They're fundamental laws of the universe, written down centuries ago, and they affect you every single day.
So let's dive into rule number 1. I personally like to call it the law of laziness. The more official name, of course, is Newton's first law of motion, also known as inertia.
Now, this is Newton's idea, in his own words, more or less. I know, it sounds a little academic, right? But the concept behind this formal language is actually incredibly simple and, honestly, kind of elegant. Let's unpack it.
The whole thing boils down to this one word, inertia. You can think of inertia as an object's built-in stubbornness. It's this property of matter that makes it resist any change to what it's currently doing.
So this completely solves our bus mystery. Basically, objects just want to keep doing whatever they're already doing. A book on your desk, it's going to stay there until you or something else moves it. When you're on that bus, your body is moving at the same speed as the bus. When the driver hits the brakes, that's the external force that stops the bus. But it doesn't stop you immediately. Your body's inertia wants to keep right on moving forward.
And that, right there, is the entire reason we have seatbelts. They are literally inertia-fighting devices. A seatbelt is designed to provide that necessary external force to your body, slowing you down safely along with the car. It's a pretty brilliant piece of everyday physics, huh? Okay, on to the second rule. If the first law tells us that things need a push or a pull to change their motion, the second law tells us exactly how that change happens. It gives us the math. This is the second law of motion, all about acceleration. To get a feel for this, just do a little thought experiment with me. Picture a giant, heavy truck and a zippy little sports car. They're both parked. To get either of them moving, you've got to apply some force, right? You've got to push them. Now, which one is going to be harder to get rolling? It's obvious, of course. But why is it obvious? What's the actual physics that makes the truck so much harder to move than the car? The answer is packed into this one beautiful and incredibly powerful equation. F equals m times a. Force equals mass times acceleration. This might be one of the most important formulas in all of science. It is the engine that calculates, well, just about all motion. So what is this really telling us? It's actually pretty intuitive. The more force you apply to something, the more acceleration you're going to get. Push harder, it speeds up faster. Makes sense. But, and this is the crucial part for our truck problem, the more mass an object has, the more stuff it's made of, the less it's going to accelerate for that exact same amount of force. That's why that truck is a beast to get moving. And this brings us to the third and final rule, which is all about a beautiful universal symmetry. I like to call it the cosmic pushback, because it reveals that no force in the universe ever acts alone. This is the famous law of action and reaction.
Come on, you've definitely heard this one before. It's one of the most quoted lines in all of science. But there's a really subtle detail here that most people kind of gloss over, and it's the key to understanding everything from how we walk to how rockets fly to the stars.
So, let's look at a rocket launch. The action is pretty clear, right? The rocket's engines blast a massive amount of hot gas downwards, pushing it away with incredible force. Well, for that action, there's an equal and opposite reaction. That hot gas doesn't just disappear, it pushes back on the rocket with the exact same amount of force, but in the opposite direction, up. And that's what lifts the whole thing off the ground. So here's the big takeaway. Forces always come in pairs. And here's the part that really blows my mind. The action and reaction forces always act on two different objects. Think about walking. Your foot pushes backward on the earth. That's the action. Now, the earth is way too massive to notice your little push. But the reaction force? The earth pushes you forward. It is literally the ground pushing you along. Wild, right? So, there you have it. The law of laziness, the math of motion, and the cosmic pushback. Inertia, F equals ma, and action-reaction. 3 simple rules that, together, explain all motion.
But, why should we care about this 300-year-old science today? Because this code is running everywhere all the time. These laws let us predict the path of a baseball, engineer safer cars and taller buildings, help athletes break world records, and, of course, they form the absolute bedrock of sending missions into space. Almost any technology that involves something moving is built on this foundation.
So let's just lock it in one last time. Rule number 1, objects are lazy, they have inertia. Rule number 2, the relationship between force, mass, and acceleration is defined by F equals m times a. And rule number 3, you can't have an action without an equal and opposite reaction.
These 3 laws don't just describe how the world works. They give us the blueprint to interact with it, to shape it. They tell us how to get things going, how to change their direction, and how the universe will always push back. So, now that you know the rules, what are you going to set in motion?